Calculating mass from volume and density. It's all well and good to compute density from data gathered in an experiment. However, centuries of men with no social lives whatsoever have populated volumes of books on the density of pretty much everything. In the daily world and in engineering, it's probably more likely you will calculate the mass from the density from one of these tables in these books put together by these men who had no life. For example, you might want to compute the weight of fuel aboard a rocket, or how much snow can load on the roof of the Sky Dome. When you go, we see 5 centimeters of snow today, how much is that actually putting as a load on the roof? Even rain on the Golden Gate Bridge will add a load weight. So density and volume can allow us to calculate these kind of things. So let's take a simple example. In movies, you frequently see someone pick up a large brick of gold. So I'm going to give you a block of gold that's 10 centimeters by 10 centimeters by 10 centimeters. So when we work it out, the volume is 1,000 cubic centimeters. So if you take a look at here, if a single cubit of gold weighs 19 grams, how much is a cubic centimeters going to have as a mass? Well, seems pretty easy that the mass is going to be the density of one part multiplied by the total number of parts in here. So mass will be density times volume. I put the density in blue because it is a characteristic physical property. It should be unique to the substance. This value here, the volume, we get to choose it. Hey, give me 1,000 scoops of gold there, and then you calculate the mass. But the density is something that you would look up in a book. So we take our two numbers, the density of gold, which is close to 20 times heavier than the same volume of water, and we multiply it by our 1,000 cubic centimeters. Please don't use your calculator. And you get 19,000 grams, which is 19 kilograms. Now, how big is a little 10 centimeter by 10 centimeter by 10 centimeter box? Well, for most of you, it's just a little bit bigger than you could cover with your hands, but it's not terribly big, right? Your hand is probably 10 centimeters long, so it's like a couple Rubik's Cubes. So it's got some serious weight to it in such a small, tiny space. Let's turn our example to a liquid and see what we'd get there. Hey there, everybody. This is the Disco King. I just got myself a new funky waterbed. Oh, yeah. It's 214 centimeters long, 150 centimeters wide, and 25 centimeters deep. How much is my bed gonna weigh? Well, we're gonna get our formula. Mass is density times volume. Oh, yeah. I'm gonna multiply all these three numbers together, and I get 802,500 cubic centimeters of liquid motion in that bed. So my bed is gonna mass 1 gram per milliliter for water times 802,500 cubic centimeters. Excuse my mixing up of those units, but a milliliter and a cubic centimeter is the same. And this comes out too that my bed will weigh 802 kilograms. Heavy. See, that wasn't very hard. We just took the volume of his bed times 1 gram per cubic milliliter, and you got 800 kilograms in that waterbed. Right? That's a ton. Almost a ton. And I did not make up these numbers. I actually got them from a waterbed company. So, yeah, that's a lot of weight to put on the floor. Right? If you consider most of the grade 9 kids are not up to 80 kilograms, you know, most of you are less than that. So we're talking like the weight of 10 people. So that's pretty heavy, man. Now, we can't all do everything in Disco Land. Cooter and Skeeter here, they're going to take a flea bath in their pickup truck. Now being rednecks, I'm going to assume it ain't a Toyota. It's some like ancient kind of thing here. So we'll just call it a Ford. Good old American Ford F-150, though. It seems a tad on the small side. And I looked it up, and a Ford F-150 has a 55 cubic foot bed volume. and the load capacity is 1 ton or 1 tonne if you're French, but as I understand, a ton and a tonne are the same amount. So we want to know how close Cooter and Skeeter are to exceeding the weight limit of their Ford 150 pickup truck with their little old swimming pool flea bath in the back there. So first thing we're going to have to do is convert this 55 cubic feet into the metric system, or the System International. And I happen to know that 1 foot is about 30 of these centimeters, and so 1 cubic foot is going to be 30 by 30 by 30. So that's 27,000 cubic centimeters in a single cubic foot, and this is a 55. So I can't drive 55. Well, I multiply 55 by this and I get 1,485,000 cubic centimeters, or about the volume of my Uncle Billy Bob's belly. Now, if you don't feel like doing the calculations by hand, well, you can just go on Google and type cubic foot, cubic centimeters, and I put in 55, and they gave me 1.55 million. You notice right down here, it said you can approximate it by multiplying by 28,317. So my approximation here was dang good. So anyway, I'm just going to split the difference, and I'm just going to say that the pickup truck is got about 1.5 million cubic centimeters in there. And again, I kind of like mix my units. Some teachers might object and say you should write water as 1 gram per cubic centimeter, but gol dong, it's the same thing. You know, it's a flea with a hat, flea without a hat, it's the same thing. So we multiply these two together, and I get out 1,500 kilograms, or 1.5 tons. So these boys shouldn't be like getting too much motion in the ocean going there, because it is right at the weight limit of that pickup truck. And that's if it's a new Ford 150. But you know, I've seen Dukes of Hazzards, and I know these vehicles can jump creeks and land on their nose and drive away. So I wouldn't be too upset about that. So I think these boys are within their safe limit. But man, where's their safety glasses? I don't know. Me in that head with the banjo, man. It's got a metal ring.